In this video, we are going to see how derivatives are useful for understanding the motion of an object in a straight line. So here, there are some quantities that we need to keep in mind. S of t is the position of the object at time t. V of t, which is the derivative of the position. This is the velocity at time t. I have a of t, which is v prime, and also the second derivative of the position, that is the acceleration at time t. And finally, if you were ever wondering if you can take one more derivative, yes, you can. A prime of t, v second of t, or the third derivative of the position. This is called the jerk at time t. It's not very common, but it measures the change in acceleration. So if there is a sudden change in acceleration, there is going to be literally a jerk. For example, when a rocket starts, okay? All right. Now, something we need to keep in mind when we say velocity, that is different from the speed, okay? Speed and velocity are different. The speed is the absolute value of the velocity. Okay, that means that the velocity has a direction. It can be forward or it can be backwards. Okay. And one more thing that I want to note is when we say v prime, we mean the instantaneous velocity. Okay, this is a derivative. But if we want an average velocity, this we get computing the rate, SB minus SA divided by B minus A. Okay. Now, we will be concerned about when objects are speeding up or slowing down. Okay, so an object is speeding up if velocity and acceleration have the same sign. Okay, otherwise they are fighting each other. And we say that it's slowing down otherwise. Slowing down otherwise. Okay, so if we have, here we have, this is a road and some object is moving in this direction. Okay, it will be speeding up. Let's use green for that. If the acceleration is going in the same direction, it will be slowing down if the acceleration goes in the opposite direction. Okay, because then it's subtracting, it's fighting v. Let's do one example. So let's say we are given the position at the time t by this function, 2 times t to the power 3 minus 7t squared plus 4t plus 1. So let's say someone was with a telescope, like following the movement of a planet or something that was not a planet, a meteor that was moving in a straight line. Okay. And according to the data that this person picked, when this person put it on the computer, the data fitted this polynomial. Okay, this polynomial was a good approximation to that, to the movement of that object. Okay, so then now is the time to make predictions. When is the object speeding up? And when is it slowing down? All right. So we just said we need to check if the velocity and the acceleration go in the same direction or not. They have the same sign or not. So let's start computing derivatives. So this is 6t squared minus 14t plus 4, right? And then the derivative of the velocity is the acceleration. So that is 12t minus 14. All right. And now we need to figure out when they are positive or negative. So a t is positive if and only if 12t minus 14 bigger than 0. That means t bigger than 7/6. Okay, this can be seconds or hours. And now, what about v of t? So this is 6t squared minus 14t plus 4. Okay, and if we compute the roots are t equal 2 and t equal 1/3. So what does that mean? Here I always like to graph it because it's a parabola, it's very easy. Okay, so we have two roots at 1/3 and 2. Let's say this is 2. That's probably too far. Let's put it here. Okay, and then because the term that goes with the t square is positive, I know it's open upwards. So then, because it has to pass through the roots, it's very easy to graph it. It's something like this. Okay, there we go. So this is my v of t. Now, where is it positive? So it's going to be positive outside of the roots. So here, v is going to be positive, and it's going to be negative in between the roots. You see, looking at the function, it's clear. It's negative or positive. Okay. So now we need to balance the two things, right? Because we want to know when the two a of t and v of t, when both of them are positive or they have different signs. So for that, we need a sign chart. We have seen this already in a previous video. So here, what we are going to do, we are going to plot 3 lines, one for A, one for B, and one for the two of them. Okay, so here I'm going to plot t equal 7/6. That's one of the important numbers. A moment, there. The other one is t equal 1/3, and the other one is t equal 2. All right. Better like that. And now we just transport those values to all the lines, and let's see what happens. So before t equal 1/3 and after t equal 2, we know that v is positive. So V positive, V positive. And then we know it's negative in between 1/3 and 2. All right. And then we also learned that A is positive after T over 6. So we put it there, and it's negative before. Okay. So now, with this information, we just need to check. For example, before T equal 1/3, they have different sign. A is negative, V is positive. So that means it's slowing down. Okay. Now, A is negative and V is negative between 1/3 and 7/6. All right, so that means it's speeding up. Because both of them have the same sign. Then the third step from 7/6 to T equal 2, they have again different signs, so it's slowing down. And then finally, A positive, V positive after T equal 2. So this means speed up. Okay, so this is how we find out using the sign chart.